Hi, I'm Josh Horstman with Nested Loop Consulting. Thanks for joining me here today at the virtual SAS Global Forum 2021. I'm going to talk a little bit about SG attribute maps and specifically how you can use them with proc SGplot to control various attributes of your plot. Here's a little bit of an overview of where we're going. We'll start with a very simple scatter plot that doesn't use an attribute map, and this is just to set the stage for what's to come. Then we'll move into a subgroup plot where we subset the data from the first plot, and this is to establish why an attribute map might be something we would be interested in. We'll move into actually using a discrete attribute map. Then we'll talk about automating the creation of something called an attribute map dataset, which you'll see what that is later. And finally, we'll finish off with an example of a range attribute map. Before we start into our first plot, let's look at the data set that we're going to be working with. Many of you may be familiar with this data set, sashelp.cars. This is one of the SASHelp data sets that ships with SAS. And it has 428 rows, one for every make and model of car that's in the data set, and 15 different columns. Now, obviously, I'm not showing them all here just for the lack of space, but I've included a few key ones that we'll be working with. In particular, besides make and model, we've got vehicle type, and you'll notice there are 6 different vehicle types. They don't all show up here in the first few rows that are on your screen, but they're all in the data set. We've also got 3 different vehicle origins, Asia, Europe, and USA, that appear in this data set. And then we've got a variety of other variables here like horsepower and weight and MSRP, which is the price, and several others that we won't necessarily use. So we're going to start with a simple scatter plot, and what we're going to do is make a scatter plot of horsepower versus weight. So we're going to have one point for every vehicle in the data set, plotted the horsepower on the x-axis and the weight on the y-axis. At the top of the code here, you'll see I have an ODS graphic statement, adder priority equals none. I want to come back to that in just a minute. There's a reason we have to include this here, but before we do, we'll talk about that on the next slide. So let's talk about the actual proc SGplot code first. You'll notice we've got a scatter statement, x equals horsepower, y equals weight. Then we have a slash, which is necessary before you start including any options on the scatter statement. And then we have group equals origin. Origin was one of the variables in sashelp.cars, and we want to see a distinct plot marker for each value of that variable. Remember, those are Asia, Europe, USA. There are 3 different values, and we're going to have 3 different types of plot markers. And then we've also set marker adders, that's marker attributes, equals size equals 10 pixels. That's going to affect all plot markers. So when I use the marker adders option on one of the plot statements, that affects all plot markers. That's fine, I want them all to be 10 pixels. Now you'll notice I have a style adders statement next. And this is to set the colors and symbols that I want for each of those 3 groups. Now I didn't have to include this statement. I could have simply allowed proc SGplot to use the default values, the default colors and symbols that are defined in whatever style is currently in effect. And that would be whatever the default style is for this ODS destination, since we haven't specified anything else. But sometimes we'd like to pick our own colors and symbols, and we could do that by defining our own style within proc template, but a lot of times that's more overhead than we want to mess with. This is quick and easy, so we use the style adder statement right here in proc SGplot. And I've said data contrast colors, that's the attribute that affects the colors of plot markers. So data contrast colors equals, and I've simply listed the colors I want in the order I want them, Indian red, forest green, and navy. I've also chosen 3 data symbols, so that we have the circle filled, square filled, and triangle filled marker symbols that will be in effect. Now this brings me to this adder priority. This controls something called attribute cycling, and this is a little bit of an aside, but I just wanted to make sure I cover this because it affects how this plot works. Here's that style adder statement again. What you have to understand is that there are 2 methods for applying attributes to groups, color priority and no priority. If we were to use color priority, then the attributes would be assigned by holding the color constant and cycling through the symbols for each group. So in other words, the first group would have a red circle, Indian red that is, the second group would have the red square, and the third group would have the red triangle, and then after having used up all the symbols, it would cycle back to the next color. So then the fourth group, if there were a fourth group, would have forest green, circle, and then the green square, then the green triangle, and so on. So potentially as many as 9 distinct groups here. However, that's not what we want. We want to use no priority. When we use no priority, then we cycle through the colors and the symbols together in sort of a pairwise fashion. So the first group gets the first color and the first symbol, so an Indian red circle, and then the second group gets the second color and the second symbol, a forest green square, and so on. However, in order to make sure that that method is in effect, we need to use this statement, ODS graphics, that's the general statement for setting options related to the ODS graphics system, / adder priority equals none. Okay, so we're going to include that once. I'm going to assume that's in effect for everything else we do in this talk. And I should mention, if you have more groups than you have defined attributes, it will simply cycle through. So if we're using adder priority equals none, and we've defined these 3 sets of attributes, and we had a 4th group, we'd cycle back to the first, which probably isn't what you want, so you want to make sure you have defined enough attributes to cover all of your groups. Here is the output from our proc-sg plot. We have the Indian red circle representing a vehicle from Asia and plotted at horsepower and weight. We have the green square for Europe and the navy triangle for USA. I also added a title. I didn't show that on the slide because there wasn't room. That's just a basic title statement. There's much more we could have customized about this plot. We can change virtually everything you see, but that's not what we're going to focus on today. In example 2, we're going to take a subset of this data set. Specifically, we're only going to look at the trucks. So this is the exact same proc-sg-plot code that we had on the first example, except I added a where statement, where type equals truck. Remember, type was one of the variables in sasshelp.cars. It has 6 types of vehicles, and truck is one of them. So otherwise, this is the same code, and we run it, and we get this output. You'll notice, of course, there are far fewer points on our plot because we're only including the trucks. Another thing you might notice is there are no trucks from Europe in the data set. So if we look at the origin or the legend at the bottom, we see the origins are USA and Asia. You'll also notice that the assignment of the attributes has changed. On our first graph, the red circle was Asia and the green square was Europe. Now the red circle is USA and the green square is Asia. So what we'd like is, for consistency across multiple plots, we'd like to keep the same mapping, even if we don't have all these origins represented on a particular plot. This comes up a lot. I work a lot in clinical trials, and we may have many plots related to a trial where we have a different color line or different type of marker for a treatment group. And maybe not every treatment group is represented in every single plot, but we'd like to have the same attributes for a given treatment group across all of our outputs. Well, attribute maps are what are going to allow us to do that very easily. What is an attribute map? Well, it's a mapping that allows you to control which specific visual attributes are applied to specific data values. In the plots that we just did, the visual attributes were assigned basically in the order that those values appeared in the data. The first value in the full data set happened to be Asia, and so it got the attributes that are supposed to be associated with the first group. So in some sense, that's a bit arbitrary. What this allows us to do is take control of this assignment process and specify the exact mapping instead of allowing it to be arbitrary. It's a 2-step process. We start by creating an attribute map data set. This is something, there are many ways to create a data set. We can do it in a data step. We can do it in proc-SQL. We can do it in any way we want to create a normal, ordinary SAS data set. And it has to follow a certain structure, which we'll look at in a moment. And then we use this attribute map data set in proc-sg-plot or one of the other ODS statistical graphics procedures. And I should mention, this is specific to the ODS statistical graphics procedures, the ones that start with SG. This is not going to work in the old legacy SAS graph procedures like gplot and gchart and gslide. That's an entirely separate graphics system. ODS statistical graphics is the newer system that has just been around the last 10 or 15 years or so. And this feature, this attribute map, applies to that system. There are 2 types of attribute maps, the discrete attribute map and the range attribute map, and we'll look at examples of both of those. And I should also mention that an attribute map data set can contain multiple mappings. We're not going to do that today in this talk, but you can have multiple mappings in a single data set, And for that reason, each mapping needs its own ID. We'll see an example of that in just a moment. To use an attribute map, we have to create a data set that is in a specific structure, and it needs to have certain columns in it. For those of you who have ever used proc format with the Control-N option, where you create a data set that contains the information that is going to be in your format, this is a similar concept. You have to create a data set that kind of specifies all these details, and then we're going to use that in proc SGPlot. There are a couple of required variables, and this is specifically for a discrete attribute map data set. You need an ID. This is a name, you make it up, any valid SAS name, an ID that we assign to the mapping. And then there's a column called value, and that's the data value that we're going to map. One word of caution on value: the value needs to match the formatted value in your data. In this case, with sashelp.cars, we aren't applying a format. We're just using these strings, Asia, Europe, USA, so we don't have to worry about that. But if you had a situation where you had a numeric variable, let's say, with a character format applied, and you were going to use that to label your levels in your legend, well, then you need to make sure that your attribute map values match the formatted values, because that's what proc SGPlot will use to look up your mapping in this data set. There are a number of additional variables that you can include in the data set, and they are things that should be fairly intuitive what they do here. You can set a marker color, marker size, marker symbol, attributes about lines, the color pattern and thickness, fill colors. For example, if you're doing bar charts, you might have bars and you can control how they get filled or what color they get filled with. You can also control attributes of text using the attribute map, the color, the family, that means the font, the weight, that is whether it's bold or not, etc. I'm not showing them all here. You can refer to the ODS Graphics Procedures Guide for the full list of variables that are allowed in a discrete attribute map data set and all the different values that are valid for those variables. You can have other variables in there too, it'll just ignore them. For example 3, we're going to recreate this plot, but we're going to do it using an attribute map. And the first step is to create the attribute map data set. And here we're going to do that using a data step. And this is a real simple way to create a data set by essentially hard coding everything in a data lines statement. So you'll notice in my data step I have a length statement. This is up at the top to ensure that each variable has enough length assigned to it so that none of these values get truncated. And I've created 4 variables: ID, value, those are the 2 required ones, and then I'm going to use marker color and marker symbol. I also have an input statement, which is going to read the values in from the data lines as if they were in an external file, but they're not. They're right here hard-coded into my data step. And then you'll notice in the data lines block, I have 3 records. I have 4 strings in each one, separated by spaces, so those are simply going to be read into those 4 variables. So all 3 records will have origin map. That's a name, I just made that up. I called it the origin map. That's my ID. The value will be Asia, Europe, or USA. And then I have an associated marker color and marker symbol. When this data step completes, we will have this data set as a result. Now it's time to use the attribute map. Here we call proc SGPlot once again, but this time we have a new option we have to use, dattermap. The D is for discrete. This is a discrete adder map, and this is where we tell it the name of our data set. I forgot to mention on the previous slide that I called my data set my adder map. And here is where I specify that that's the data set that we're going to use as an attribute map. I also need to tell it which specific mapping within that data set to use, because remember, you can have more than one in the same data set. So here's where we specify that ID. Adder ID equals origin map. That was that ID name that I just made up. That goes on my scatter statement. You'll also notice I have gotten rid of the style adders statement. We don't need that anymore because we're going to be using the attribute map to specify colors and symbols. And here is our output. Notice now that the attributes have been mapped the way we specified. We have the navy triangle for USA and the red circle for Asia. Now, one thing you might be wondering is, hey, these aren't in the order that I want them. Can I fix the order? Can we put the legend back in order so Asia's first? Well, yes, we can. We're going to make a little bonus tweak here to our code. by simply adding the key legend statement. And the key legend statement lets us control various features of the legend. We're going to just look at one, which is the sort order equals ascending. That's simply going to sort the values in ascending order in the legend. And now we get Asia and USA. But you might be wondering, can we add Europe to the legend? Even though there aren't any trucks in the data set from Europe, it might still be nice to have it in the legend so people know that we didn't just exclude Europe, that simply weren't any. It turns out we can do that, but we need to modify our attribute map by adding one more variable. There's a variable called show. I've added it to my length statement and my input statement. And I've added a value to the end of each record in my data lines, and the value is attrmap. The valid values here are attrmap or data. Data means just show the legend entries that are in the data. Attrmap means show everything that's in the attribute map, whether or not it's in the data. Here's our new attribute map data set that comes out of this data step, and here is the resulting plot. You'll notice that we have Europe in the legend now. Let's talk a little more about a different way to create your attribute map data sets. Personally, I try to avoid hard-coding data values if I can, so here's a different way to create the attribute map data set that doesn't require hard-coding them. Here I do a proc sort of my data set, sashelp.cars, with the no dupe key option in effect, and I'm only keeping the variable origin. And this is going to give me a little data set that just has the variable origin and just one row per unique value. So this tiny little data set with one variable and 3 rows. Then I'm going to take that data set, read it into another data step to make my attribute map. Notice I'm renaming origin as value because that's what the attribute map is expecting. And then I have my length statement, and then I have a couple of statements here to set my marker color and marker symbol. And I'm making use of the choose-C function, which is a convenient way for me to assign Indian red to the first record, forest green to the second record, and navy to the third record into the variable marker color. Choose-C simply returns an item from a list. The first argument is the index of the item you want, and the rest of the arguments are the list of things that can be returned. You could have done this with some if-then-else logic, but I find this to be convenient. I have another paper that is out on the web you can look up if you want more information about the choose-C function. It has to do with conditional logic in SAS. Then we hard code the ID and show variables since they're going to have the same value for each row in our data set. And now this creates the exact same data set that we had before, except we did it without hard coding any of those values into our code. So this is handy because what if our values might change in the future and we don't want to necessarily change the code. This is all been using a discrete attribute map. There's one other type of attribute map called a range attribute map. And I have one final example to show you that. The difference here is that instead of including a value for each row in our attribute map, we include a min and a max. Now for this example, instead of using vehicle origin, we're going to use the vehicle price, since that fits nicely into something we can divide up into ranges. So I'm going to color the points where the price is less than $25,000 teal. You'll notice the use of the special keyword _min_. So that means anything from the minimum value in the data set up to 25,000 is going to get colored teal. From 25,000 to 50,000 will be colored purple, and from 50,000 to the maximum will be colored dark orange. You'll also notice I'm using this variable alt color, not marker color, which we were using before. The range attribute map data sets have different variables that do different things, and if you refer to the documentation, you can find out what the requirements are. This will create an attribute map data set, which we can now apply using proc-sgplot. You'll notice instead of dattrmap, I've used the rattrmap option on proc-sgplot to specify the name of the data set, which in this case was myattrmap2. I've applied some attributes to all the markers using the marker adders option, but I've used these two additional options to control the marker color. Color response equals MSRP tells the proc-sgplot to use that variable, MSRP, that's the manufacturer's price, use that to determine the color in conjunction with this attribute map, with the ID value price map. And on the previous slide, you may have noticed price map was what I called my attribute map. That was the name of the ID variable in the data set. And when I apply this attribute mapping, I get this beautiful graph, and you'll notice I have a nice scale off to the right that shows the different ranges of values and what they represent. In conclusion, attribute maps let us associate specific visual attributes with specific data values or ranges of data values, and this has several advantages. It allows us to have consistent attributes across multiple plots without having to do a lot of extra work to get them. It eliminates dependencies on the sort order of the data. Normally, attributes are assigned based on the order that values appear in the data set. If we don't want it to be dependent on that, we don't want to have to worry about what order our data is sorted in, we can use an attribute map. And as we saw, we can even use it to include legend entries that are not found in the data set. I should mention you can also use this with other SG procedures, not just SGPlot, but also SGPanel, SGScatter, and SGPy, for example. And as I mentioned, there is a SAS 9.4 ODS Graphics Procedures Guide, which you can get for free at support.sas.com, that has all of the details, exactly what's required for these attribute map datasets and how to use them. I hope this has been a helpful overview of the SG attribute maps. And thanks again for joining me here at the virtual SAS Global Forum 2021. Hope to see you in person next year.